The Spectral Acceleration Maps of the Philippines, ATLAS, is the latest probabilistic seismic hazard model developed and published by the Department of Science and Technology, Philippine Institute of Volcanology and Seismology, in technical collaboration with the Global Earthquake Model Foundation, Hazard Team, and Geoscience Australia, and also in close consultation with the Association of Structural Engineers of the Philippines Project SAM Committee.
The spectral acceleration maps of the Philippines Atlas is significant because it represents a major scientific advancement in the quantification of seismic ground shaking in a complex and vulnerable region. The effort involved a deep collaboration between PHIVOLCS and the GEM Foundation, and the result is a very high-quality product made from the most informed datasets and state-of-the-art practices in probabilistic seismic hazard modeling.
Nowadays, major infrastructure and buildings are designed using performance-based design approaches. As a practitioner engineer myself, I consider the seismic input as a key parameter on the design process. This is why the publication of the Seismic Acceleration Map of the Philippines is a fundamental tool for structural engineers, since it's based on an accurate and validated seismotectonic model.
Atlas is a really useful tool for identifying localities in which hazard is the highest, and so where greater measures need to be taken when building critical or vulnerable infrastructure facilities. For example, identifying places where they should not be built, or places where significant engineering and cost commitments would be required in order to do so safely. And so this can help make priorities about which buildings need to be retrofits. Another way that the Atlas can be used is to identify places that are likely to have major interruptions or impacts due to earthquakes, to help plan ahead for potential earthquake scenarios and allocate resources appropriately.
The Spectral Acceleration Map SAM-PH Atlas is a very useful tool in disaster mitigation and risk reduction. The study made by PHIVOLCS in arriving at the maximum credible earthquake modeling became the basis for ASEP to arrive at the Seismic Acceleration Map to be used in developing the National Structural Code of the Philippines earthquake design provisions. This knowledge of seismic source activities will better assist the Filipino engineers come up with a more economical, safe, and efficient structures for the Philippines setting.
It is useful because mainstreaming hazards such as destructive ground motion helps protect the community, resources, and future public investments. In the area of resilience quantification, we can use it to estimate the robustness of a building or a lifeline structure such as a water distribution or power or communication network.
I think there are some gaps in the current seismic provisions of the NSCP that were addressed by the SAM-PH Atlas. I think the most significant or notable is the ground parameters used for seismic design. In the current seismic provisions, 12 uses zones for the Philippines. As the new edition of the NSCP adopts the ASTE7 standards, the current seismic zones now will be replaced by contour maps of MCE spectral acceleration. These, of course, are at short periods and at 1 second period for Class B soil or rock type. And of course, this will now be incorporated in the new edition of the National Structural Code of the Philippines.
The Atlas is very important to us. It's a significant step toward the use of the hazard model for the definition of the effective measures for earthquake risk reduction. Despite the limited resources available, the hazard model that we developed together with PHIVOLCS incorporates state-of-practice methods for the construction of probabilistic seismic hazard models.
With the first phase of SAM-PH Atlas, in which MCE hazard maps are now ready for publication and for use by Filipino structural engineers, building officials, government engineers, and even foreign engineers doing projects in the country. When these maps are integrated in the next edition of the NSCP, we are looking forward to a swift transition to adopt the ASCE 7-16 from ASCE 7-05 to formulate and generate risk-targeted coefficients for the maximum considered earthquake response acceleration parameters. That is, of course, shifting from MCE to MCER. This will be definitely the next technical collaboration between ASEP and DOST-PHIVOLCS.